Welcome back, ladies and gentlemen. As promised, I did say I was going to create a video for lesson 1, so unit 2, uh, radicals, operations on radicals, lesson 1, class example 2B, right? So I did say that I was going to create a video for you for this because I couldn't get my projector and stuff working in class yesterday. So here we go. I will post this on YouTube as soon as it's complete, and you'll have access to it. If you want a picture of it, you can snap me, and I have a picture as well if you wanted that instead. So with addition and subtraction of radicals, the key thing that hopefully you've picked up so far is that the index of the radical and the radicand of the radical have to be the same in order to be able to add and subtract them together. So having the index and the radicand the same basically creates what we call a like term, and you can add and subtract like terms together. Okay, so what you see in this question is that there's 4 different radicals, all with the same index, but all with different radicands. So the first step in any process is really try to get your radicals as simplified as possible so that you can see if they are like radicals or not. Okay, so we're going to have to do some side work first in order to simplify all of these radicals. So somewhere in some scrap paper, you're going to simplify the cube root of 64, the cube root of 375, the cube root of 54, the cube root of 24. Okay, so I'll do that separately just off to the side here. So the cube root of 64, cube root of 64. Maybe you know it already. Maybe you know that 4 times 4 times 4 is 64, and you can say straight away that, oops, what did I have? What did I do? Okay, you can say right away that that is equal to 4. Okay, if you don't, then you're going to go through the process of prime factorizing, and you're going to break 64 down, and it's going to break into 6 2s. So it's going to be 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So really, the cube root of 64 is 2 times 2 times 2 times 2 times 2 times 2. And with cube root, we look for groups of 3. So there's our group of 3. That's going to pop out. And there's another group of 3. That's going to pop out. There's nothing left over. So really, the root sign disappears, and we end up with 2 times 2, which is equal to 4. Okay? So back in our question, this cube root of 64 now simplifies to 4. So this is a straight up 4. So I could rewrite this as 4 over 8. And then I'm going to simplify the cube root of 375, cube root of 375, which is 3 times 125. And oh, look at that. That's a perfect cube root. So if you know perfect cube roots, you know that this is going to be 5. Okay? Or you can keep factorizing, prime factorizing, 25, 5, 5. That's going to give us the cube root of 3 times 5 times 5 times 5. There's our cube root. There's our 3. So he's going to, the 5 is going to pop out. We're left with cube root 3. So 5 cube root 3. So this simplifies to 5 cube root 3. So I could rewrite this now as plus 2 times 5 cube root 3. And of course, I'm going to simplify the 2 times 5 in a minute. So now I'm going to do cube root of 54. Cube root of 54, which is 2 times 27. And there's our perfect root. You can see it. 3 times 9, 3 times 3. So the cube root of 54 is really 2 times 3 times 3 times 3. There's our group of 3s. That pops out. That gives me a 3. Cube root 2. Okay. 3 cube root 2 is what this 3 cube root 2 simplifies to. So this is going to be minus 2 times 3 cube root 2. So you can already see we have 2 different radicands, and we're not going to be able to combine these 2 terms together. Okay, so yeah, sometimes they don't simplify all down into one nice little radical, and sometimes they do. So you just have to make sure that you're working through it and paying close attention. So now we have one more to simplify, the cube root of 24. So cube root of 24. Again, somewhere I'm doing my scrap work. Cube, oops, didn't need to erase that. Cube root of 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So that's the cube root of 2 times 2 times 2 times 3. There's our group of 3. That pops out, left with cube root 3, 2 cube root 3. So 24 simplifies to 2 cube root 3. So this is now going to change to minus 5 times 2 cube root 3 all over 2. Oh, I forgot the fraction over here. This is all over 3. This 3 hasn't disappeared yet. So now we have our simplified radicals. Now we can start simplifying those radicals together and then seeing which ones we can combine, right? So if we reduce 4 over 8, both 4 and 8 divide by 4. So this is going to become 1 over 2. Plus 2 times 5 is 10, cube root 3. Minus 2 times 3 is 6, cube root 3. 6 cube root, sorry, not 3, 2, all over 3. Don't worry, we'll deal with that fraction in a second. And 5 times 2 is 10, cube root 3, all over 2. And you can see that this 6 and 3 are going to reduce to 2. This 10 and 2 are going to reduce to 5. So now I'm going to quickly rewrite this. 1 over 2 plus 10 cube root 3 minus 2 cube root 2 minus 5 cube root 3. There's no other constants I can combine the 1/2 with, so it stays as 1/2. I can combine this 10 cube root 3 with this minus 5 cube root 3. So 10 minus 5 is 5 cube root 3. And then this one's lonely, no other things to simplify with, minus 2 cube root 2. And there's that example finished, okay? So adding and subtracting radicals, the key to remember is that you have to have the same index and you have to have the same radicand. And then you can add and subtract as much as you like, okay? I will post this to YouTube right away so that you guys have it, and we will see you next time.